All right. Hello, everybody.
Hey, everybody. Welcome back to this week's episode of Dome to Home, brought to you by Fiske Planetarium. My name is Rémy. I'm an astronomy student at CU Boulder and a presenter at Fiske. And below me, we have...
Hello. It's been a while. My name's Amanda. I haven't been on for a couple months. Maybe it's just been a few weeks, but it feels like longer because I really miss connecting with you guys. But I'm excited to talk about exoplanets today.
We're thrilled to have Amanda back. Also helping us today behind the scenes is Emily, who's going to be our chat moderator and question master for the day. So feel free to hop in the chat, say hi to her, hi to us. If you have any questions throughout the show, you can either send them in the chat or to our submission form. Emily's going to put a link in the chat, or you can find it in the video description. So your questions are going to be answered live. So anything that you're curious about, anything, just ask. And you can send them during the show, or we'll also have time at the end dedicated to your questions. So definitely, if you're curious, let us know. Before we get into the show, though, before we get into exoplanets, viewers who watched us last year might remember that our fall series was dedicated to a very special spacecraft.
When the human race is asking questions bigger than the Earth itself, we must have perseverance. The mysteries that Mars holds are deep and never-ending, and only one rover can find them out. That rover has made the tireless journey to Mars, all on its own, to unlock the secrets that Mars keeps hidden away. That rover is Perseverance. Now streaming on Mars, rated E for everyone.
That is right. Perseverance rover has landed just last Thursday. So Perseverance and its little helicopter Ingenuity, you might remember we were really loving Ingenuity, have landed safe and sound on Mars. They're both doing fantastic. And if you want to learn more about what Perseverance is doing on Mars, we have our whole series available on YouTube. So you can watch those anytime you want. Watch them again, watch them for the first time. They're all really good. And if you want to watch the rover land, there's a really cool video. Emily's going to go ahead and send a link in the chat.
Also, we have talked about doing some kind of movie trailer probably every time we prep for a Dome to Home show. So we can't even begin to tell you how exciting it was to put that together. And I hope you guys had as much fun as we did, because it was silly, but it was fun. So hopefully you guys enjoyed that.
The music was my favorite part. Maybe we'll start doing previously on Dome to Homes at the beginning. Yeah. So that's the latest on our neighbor. But what about our distant fellow planets? We're going to be wrapping up our month of exoplanets this week by taking a peek into the future of exoplanet discovery and research.
Yeah, so let's do just a quick recap to kind of refresh everybody's memories, or get any new people up to speed if you haven't been here before. So, and what is an exoplanet? An exoplanet is just a planet that is not in our solar system. It's orbiting something else, a different star. Some of them are huge gas giants, and some of them are little icy guys. There are rocky guys. We've got planets close to the sun, far from the sun. There's a whole variety out there. And if you know of our friend Kepler, Kepler has found a lot of exoplanets out in the galaxy, and even beyond. And we can show these little dots just to give you an idea of how many exoplanets we've found. So now each one of these dots is its own exoplanet, and there are over 4,000 exoplanets just discovered from Kepler. So what now? How do we top ourselves?
How do we top ourselves? Well, it feels like we've done a lot with exoplanets, but it is actually kind of a new field. It's exciting, booming field of research, getting more and more attention, not just from the public, but also from more scientists and science agencies around the world. There are a huge number of missions planned and underway that are going to teach us more about exoplanets. So our galaxy has billions of planets in it, and we've really only discovered an extremely tiny fraction of those. Even the 4,000 that we've confirmed, and there are a number of thousands that we're waiting to confirm, it's not a full picture with those, and we don't even have a full picture of each one. A lot of them are just, well, we know this one's a gas giant and it's close. So that leads us to a recent mission that's kind of just getting going. It's a European Space Agency mission called 𝐀𝐜𝐿. It stands for Characterizing Exoplanets Satellite. 𝐀𝐜𝐿. That was a reach within my opinion, but you know what? We'll go with it. This satellite isn't going to be looking for new exoplanets. It's actually going to just tell us a lot more about the ones we've already found. So the satellite has been up for just over a year now and operating since about April. Its mission is to tell us more about the sizes of exoplanets, their atmosphere, or even if they have like exomoons or exorings. If there's another Saturn out there, we might be able to see that. And it may even reveal more planets in a system than we originally thought. So using data from 𝐀𝐜𝐿, we can actually get a much clearer picture of the exoplanets that we discover, giving us a clearer picture of how planets work at all. So 𝐀𝐜𝐿 is expected to continue its work for at least a few more years. So as scientists pour through all of the measurements and data, expect a lot of really cool, interesting finds. So there's 𝐀𝐜𝐿, looking cute. So we're actually going to be launching a number of missions within the decade that will teach us a lot about exoplanets, including the infamous and long-awaited James Webb Space Telescope. Yay! The telescope is actually set to launch in October of this year. 2021 is the year, folks. We're going to do it. My fingers are crossed. James Webb has been a huge undertaking. Its development has been spanning a very long time. It originally began in 1996 with a planned 2007 launch. Things don't always quite go as planned, but it is on track for October, last I heard, which was a few weeks ago.
Please.
It's going to happen, Amanda.
Please.
It's going to happen. We believe. So yeah, James Webb Space Telescope is like the telescope that we've been waiting for. And look at how big it is. That thing is giant. And bigger, isn't always better as a general rule, but in the case of telescopes, it definitely is. The bigger your light collector, the better the telescope can see. James Webb Space Telescope is going to see much farther, much clearer than many, many, many of its predecessors. Just take a look. You can see its mirror compared to Hubble. Hubble looking like a hubcap over there. This thing is giant.
It is pretty impressive.
Yeah, you can see it compared to all the people working on it. It's nuts.
Yeah, but Rémy, we can't just send this thing up into space like that, can we?
No, we can't. That thing is so large that we won't be able to send it to a spacecraft like that. It's just too big to go in one piece. So it's going to fold up and then unfold very carefully when it's ready to be deployed. And it is just such a cool sequence of events. If you watch here, there are so many things that are going to happen as it unfolds here. So it's got all of its little parts.
Definitely very anxiety making. There's a lot of moving parts.
I won't be able to watch any of this live or hear any of this live. It's going to stress me out too bad. But it's an incredibly neat spacecraft. What it's going to be doing is looking in infrared light. And I think Tara was talking about this a little bit last week. Infrared is like heat. So it's going to be trying to do direct imaging of planets. So instead of just looking for how planets affect the starlight or anything like that, what James Webb is going to do is kind of like block out the star so that it can see the little planets around it. So to see an infrared, James Webb has to stay very, very cold, like -300 degrees Fahrenheit, 350 degrees Fahrenheit. So it's going to stay shielded from the sun so that it doesn't get any heat or warmth that's going to give us any false readings or mess anything up. it's going to be doing a lot of other work. So it's going to be looking at faraway galaxies that even Hubble can't see well. It's going to be trying to find the first stars. But a major part of this mission is to learn about the formation of stars and planetary systems, to study the planetary systems, and maybe even learn a bit about the origins of life itself. So that's very neat.
We've got a big mission for sure.
Yeah, we might even be able to see a little bit about like the atmosphere of rocky planets. It should be really cool.
So cool.
Gosh, there's just so much that has to go into that deployment.
Just launch already.
Please. But James Webb isn't the only upcoming exoplanet mission. NASA also has a mission called the Nancy Grace Roman Space Telescope. It's currently slated for launch in the mid-2020s. Hopefully so. The telescope is actually named after former stellar astronomer Nancy Grace Roman. You can see her there. She was the first woman executive at NASA, and she's known as the mother of Hubble due to her extensive planning on the Hubble Space Telescope. So this telescope, the Roman Space Telescope, like James Webb, will be multi-talented. It'll be investigating dark energy, actually, along with exoplanets. Unlike, James Webb, it's not going to, well, it will be able to perform direct detection, but it is also going to use a technique called microlensing. And Tara, again, also talked about this last week. So if you want to know more about it, go ahead and check that out. But basically, it's looking at how gravity from an object with mass, bends light around it. So you can see it right over there. So light gets bent around an object with mass. And that's the whole relativity thing. And we can look for that. And this telescope, the Roman Space Telescope, is going to be so sensitive that it will be able to detect like rogue planets, if you remember those, the planets that aren't orbiting any stars, ones that are around the mass of Mars. So that's not a lot of microlensing. This thing's going to be able to detect it, which is just mind-blowing. It's incredible. So hopefully this mission gets the mid-2020s launch that they expect, because dark energy and rogue planet microlensing sounds really neat.
Even just the expression, like, oh yeah, man, have you heard of the rogue planet microlensing? That sounds really cool.
It's the name of my new band.
But of course, we can't just stop with a few. We have to have plentiful amounts of these exoplanet hunters. So yet another one on our timeline is named Plato. And Plato is from the European Space Agency. It's set to launch in 2026. So it's got a little bit of time for them to work out all the kinks and really get ready. It stands for Planetary Transits and Oscillations of Stars. So not too much of a reach, but they're trying. And just from transits and oscillations of stars, you could probably guess what it's going to do. It's going to help us understand conditions for life by watching planets transit their star, maybe learn a little bit about their atmosphere. It's definitely going to be focusing on terrestrial planets and their distance from the star to kind of determine whether or not they're in the habitable zone, like how we're in the habitable zone around our sun. So it's gonna, like I said, it's gonna learn about them through transit, and it's gonna do this cool thing called astroseismology. So like earthquakes in stars, which, yeah, I think Rémy titled it correctly as starquakes, which is also maybe a great name for a band.
Starquakes, I'm about it. That's my EP.
So together, Plato will be able to tell us a lot about planetary systems as a whole and how they evolve over time, along with all its colleagues.
So it's really neat. We're going to be able to see a lot about even just one system, a lot about life, focusing on stars like our sun. Very cool. ESA actually has another exoplanet spacecraft in the works. It's called Ariel, and this acronym actually works really well. It's Atmospheric Remote Sensing Infrared Exoplanet Large Survey. There are no midword letters, and I have to give them credit for that. Ariel is actually planned for launch in 2029, and it should hopefully tell us a lot about exoplanets' chemical composition and physical, conditions, including their atmospheres. So a lot of these telescopes are really going to be able to tell us a lot more about maybe even Earth-like planets. It's very cool. As we've been saying, exoplanets it's a huge and fascinating field of study, and the future is just chock full of mission plans, research proposals galore. But I suppose, when we talk about the future of exoplanets, one of the big questions is why? Why do we care about these planets that are just so far away? And for starters, learning about these faraway planets help us learn more about our own as well. They're an incredible source of knowledge on how planets are formed, why they are how they are, and what the future may hold. Seeing all these planets far away has expanded our vision of the planets close to home and has actually shaken up a lot of our preconceived notions and ideas. And I do think that a large part of our interest in exoplanets really does come from a natural human curiosity and an innate desire to learn about everything that we can get our hands or eyes or telescopes on. We want to explore and to discover and understand. We want to know, more about the unknown out there. We want to know more about where our own planet came from, whether there's anything like Earth, like us, out there. This field is only getting bigger and brighter. So if you thought this month's Dome to Home was really interesting, you are in fantastic luck for the future. So we have plenty of time for any questions.
And, I think it's just really just to emphasize on that last point that Rémy was saying, I think the biggest questions that human beings could ever ask is, where did we come from? And are we alone? Because if you've been following Fiske's YouTube channel for a day or a month or years or anything, you know that there are millions and billions of stars out there that all have, or not all, excuse me, but most of them have exoplanets. And the fact that we're here and we're unique is really suspicious. There should be something else out there, right? We want to find it. And this is how we start doing that. We start with what we can do, and what we can do is finding these exoplanets. Now that we've found thousands of them, it's time to take it to the next level and say, well, what can we actually learn about these planets, and what can that tell us about our own planet? So, I hope you guys are as excited about this as I am. I really can't wait to see the first spectral signature from an exoplanet atmosphere.
It's going to be so neat. We do actually have a few questions. So we've got, do you have a favorite exoplanet? So people who saw the one about different wild and wacky types of exoplanets might remember how enthusiastic I am about rogue planets. I really love the idea of rogue planets. The sun and I don't get along. It's too hot. It's too bright. The idea of going to visit a planet where you just don't have to worry about the sun is fantastic. That's my favorite type of exoplanet. I really couldn't tell you which one of them I love the most, but that's, I guess, what brand of exoplanet I like best, genre. What about you, Amanda?
Exoplanet, I love it. I will have to admit that I am shamefully unaware of a lot of exoplanets out there, but I do think the TRAPPIST system is really cool. It's, one of the first few exoplanet systems that we got to look at. Here, I'll see if we can find a quick picture of it. And I just think it's really interesting because, well, I love Jupiter. I'm a big Jupiter person, and I think the resonance of the moons is really neat. Sometimes they'll all line up, sometimes 2 of them will line up, sometimes 3 of them will line up. Well, on the TRAPPIST system, you have 7 planets. And so you have the potential to get 7 planets lined up. Now, I don't think they ever actually all line up, but even just getting a conjunction of 4 is really neat. So
that's interesting. Usually people, when they talk about the TRAPPIST system, are like, and there are cool planets in the habitable zone. I never really thought about how the orbits go around.
The dynamics.
Yeah,
man.
that's a neat way to look at it.
Yeah, Emily, if you have one, feel free to drop it in our chat too.
Yes.
Or anybody else watching, if you have a favorite exoplanet that you love, let us know about it. Like I said, I'm pretty uninformed about exoplanets, so if you have a cool one for me to check out, I'd love to look.
Yeah. We've got Ari Sprite says, which telescope coming soon are you most excited for? I want to say James Webb Space Telescope, but I feel like that's going to jinx it. We've just been waiting so long for it, and I'm really, really excited. I'm really excited to see it up and working. So, I mean, I've knocked on my wood desk, so hopefully that takes care of it. I'm really excited about it.
Yeah, I have some pretty mixed feelings with James Webb because I agree. If it would just frickin' go up there and do its job, I would love to see what it had to offer. But I feel cheated with all of this back pushing.
Oh, no.
But at the same time, I'm
It's gonna be
grateful
so
because
cool.
I'm glad they're making sure it's working before they're putting it in space. So I appreciate that.
It's better that they're making sure that this thing is going to work. If they had launched it sooner, or when they originally thought, then that whole unfolding sequence could have completely failed. Everything could have gone wrong. It's always good to quadruple check that your equipment's working before you send it up there.
And from our prep, I kind of think I'm most excited for Ariel because, I'm also an atmospheric person. I like atmospheres, I like atmospheric dynamics, that kind of stuff. And since Ariel is going to be doing atmospheric remote sensing, that's something I'm really interested in.
Absolutely. We've also got which exoplanet do we know most about? So the more measurements we can take of an exoplanet, the more we can know about it. So for example, that 𝐀𝐜𝐭𝐢𝐯 mission is going to be learning more about the exoplanets. If you learn about an exoplanet from, we were talking last week about Doppler shift a little bit. You can watch how gravity makes the star move back and forth. Then you can figure out the mass of an exoplanet. So you can say there's an exoplanet here and it's about the mass of Jupiter. But you don't really know a whole lot more about it. You can kind of assume, well, it's probably a gas giant based on that. But if you can also get a transit, when it goes in front and blocks some of the starlight, you can also get the size. So that 𝐀𝐜𝐽𝐸 is going to be looking for the size. From that, you can also tell about the density. Then you can tell the composition. If you can get the right spectra, you can even learn about what's on the surface, what it's made of, what the atmosphere is. The more we look at an exoplanet, the more we're going to learn. And the better the exoplanet is placed, the better we can do. I don't know that there's a specific exoplanet that we know the most about, more than any other ones. But the more telescopes we can use to look at the same exoplanet, the more that one's going to be top tier knowledge. We've got, how long would it take for us to travel to an exoplanet? Depends on what speed you're going. If you were going light speed, so if I had a laser pointer and I shone it at the next star, for example, the next star is about 4.5 years away. If you're a laser pointer, if you're light. Most stars have planets. Most every star that we look at has a planet. They're very, very common. So it stands to reason that it would be within a few light years. It would only take a few years going the speed of light. Going warp speed, I think it's just a few, hours.
Warp speed.
But if we hit warp 5, we'll be there in a couple days. But light speed, it's a few hours in between, but it could take up to thousands of years depending on how far you're going.
And if you guys have a piece of paper in front of you, 4 light years is about 2 with 13 zeros behind it miles. So if you really want to know how far 4 light years is in miles, put a 2, put 13 zeros behind it. That's a big number.
11, 12, 13. It's a lot of zeros. That's tough to even imagine. We've got telescopes in space can see way more. But would an Earthbound telescope be able to see any exoplanets or anything like that? So there are a lot of different benefits, like pros and cons, to putting a telescope in space versus on the ground. If you have a telescope on the ground, you can make it much, much bigger. You can make a huge telescope on the ground, ginormous. And if you have a bunch of telescopes working together, you can pretend you have a telescope the size of the Earth because they're all looking at the same thing. So that's a huge positive. One thing that kind of sucks for trying to do telescopes on the ground is that our atmosphere is in the way. Atmosphere, super great for breathing and living and all of that good stuff. Not great if you're trying to do astronomy in, say, like X-rays or ultraviolet, or if there's a lot of turbulence, like a lot of wind or a lot of clouds. So you really are kind of at the mercy of whatever the atmosphere is up to, and what kind of light the atmosphere is blocking. The reason we like to put telescopes in space is because we don't have to worry about that atmosphere causing problems or making it difficult to see through. We can see a lot better more than anything else. So you can see better from space, not necessarily always further, because you can't quite get as large of a telescope. It really depends what you're trying to do. There are ground-based telescopes that look at exoplanets. Some of our coolest imagery of like circumstellar disks, these like protoplanetary disks is the word I'm looking for. So that's when stars are still forming and you've got this huge cloud of gas and dust going around that are eventually going to become planets, come from ground-based telescopes. I think, do we have some of those in the system?
Yep, I'm looking for it right now. There's some
Yeah.
beautiful pictures. Yeah, I think I found them.
Ooh, excellent. Yes. These are gorgeous. So these are baby stars with all this gas and dust, and eventually those are going to be planets, and you can see their rings where the stuff's coming together and is going to form planets. These are really neat, and this is all ground-based. So it just kind of depends on how you want to look at the sky.
And also, just for anybody that's been watching for the past few minutes and is just seeing all these rainbow colors coming at you, we were flying through our exoplanets. So we saw all those little dots everywhere earlier when we were close to home. But once we flew out of the solar system and started kind of flying around in our galaxy, we could see the spatial difference between those. So they're not just dots painted on the sky, they're all at different lengths. And so right now we're just kind of flying through the exoplanets that we know of, and we know their locations.
Turns out it only takes a few seconds to get to an exoplanet. I'm so sorry.
Yep.
if we're flying in here.
If you have the awesome power of the planetarium, you can break all kind of physics rules.
So we've got, it seems impossible to keep a moving telescope fixed on a teeny dot of a distant exoplanet. How do they do it? How do they do it? It is very difficult to keep looking at the same spot. And we're looking at really, really, really tiny, 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 tiny parts of the sky. So you have to make sure that your telescope is just going to move with your target. That's going to keep looking where you want it to look. And that's a lot of engineering that's a little far outside my area of expertise, but it is really tricky to be doing that, to just be looking at such a tiny part of the sky for as long as it does. Yeah,
it's
that's a fantastic question.
It's a little bit easier for ground-based telescopes because we know how fast the Earth rotates, and so we know when stars will rise and when stars will set. So sometimes it's easy to look for objects that are farther out in the solar system that way. But yes, in space, it is a completely different ballgame.
Yeah, a lot of telescopes, you can just plug in what you're looking at and it automatically moves with it. It's really neat, the amount of things people come up with and can do to deal with those sort of things. Do they have a backup to the James Webb Space Telescope in case the launch fails? I don't think so. We've got like another model and everything. We know how to build another one, but I don't think that they have built a second one as a backup. We're just kind of really banking on this one.
I was gonna say, if the first one fails, would I even want a second one up there?
I would.
Of course we would. We want to get all the information.
100%. Yeah. What Emily said, they might have a backup in another 20 years. So Mr. McFarland says, are we observing motion within the galaxy like spiral arms and other solar systems, and then confirm mathematical ratios? I'm not sure about the second bit, but we can detect like motion within the galaxy and see how things are moving. There are some movements that just take so long that we just can't really see it. And we kind of have to extrapolate based on the tiny, tiny movements that we can see, movements we see other places, and based on math and models. So we know that things are, going around the galaxy. We know that the spiral arms move around the galaxy, not exactly at the same rate as the stars, kind of like a traffic jam. We know that planets are moving around their stars, around their suns, because that's the way that we actually even detect them. If they didn't move at all, then we wouldn't be able to see them or do anything with them, really. And doing that confirms a lot of our math, or it gives us new data to create new equations in new math. If it turns out something we have doesn't really work. That's a lot of research, is saying, I think this is how the math works. This is great. This is my model. We've got it. We understand everything. And then looking at something, seeing that it doesn't move how we thought. And we've got to kind of go to the drawing board. So we're observing a lot of motion.
And it really depends on what we're looking at too. Like, things like asteroids, their orbits change all the time because of different heating from the sun. So there are a lot of variables out there to keep track of.
Yeah. There's a lot of movement happening. Earth turns, Earth goes around the sun goes around the Milky Way moves around, space is expanding. We're going very fast even when you're sitting still. Someone says, get up and move. You're always staying still. It's not true. If you have any other questions, feel free to pop them in the chat. It can be something about exoplanets, something about what we talked about. We're perseverance experts if you have any questions on that.
Yeah, let us know if you liked our
space
trailer.
In general. Absolutely. Because now is the time. You've got 3 experts at your disposal. Meantime, wow, that is so many exoplanets.
So many, I know. I'm impressed. And I think the most recent we've updated our exoplanet data set was 2018, 2019.
I think something like that.
So we definitely don't have all of the exoplanets that we know of.
And yeah, like we said earlier, with 4,000, when we say there are 4,000 exoplanets we found, those are just the ones we've confirmed. We've got a ton of data on other candidates and possibilities. As new telescopes discover more exoplanets and planetary systems, do you think our solar system will become more unusual or more ordinary? God, that's such a great question. Because as it stands, it's kind of looking like we're fairly unusual. And that's just because our detection methods really favor very large planets that are really close to their star. Again, the more about how we find them in last week's video, but the larger a planet is, the more it interacts with its star, the more light it blocks, the more it can micro lens light around it. They're much easier to find. So we look and we're like, wow, there are a lot of really big exoplanets, and there are a lot of exoplanets that are really close to their star. Are we weird? But it could just be that those are the easiest ones to find. So we have a lot of them. If it's just kind of like a sample bias. I personally don't really know. I think it's just going to be a grab bag. I think everything is unusual in its own right.
And I like this question, when will sample return mission take place? I'm assuming you're talking about Perseverance, since we said we could answer questions right before that one came in. Yep. And Rémy, sorry if you already said this, but Perseverance isn't planning on sending samples back until 2031, so 10 years.
Yeah. Those are going to have to be picked up. So Perseverance doesn't have a little rocket to launch them. So we need someone to actually go there and like physically retrieve them.
Yep, and it's going to be the Mars Sample Return Mission, so MSR.
It'll be super neat. In the meantime, we've actually recently had a sample return mission from an asteroid, and we'll be having a few more, so that's really cool. Hayabusa 2 came back a few months ago. Sample return missions are really difficult because not only do you have to get the spacecraft there, you then have to get the spacecraft to pick something up and then get the spacecraft to bring it back. So there's a lot of things that have to go on there. So we tend to usually send things to study them at their source, but we can do so much more when we actually have the material with us, which is why we like to do the sample return missions. Yeah, how could space ever be ordinary? Everything's exciting. I guess I think the weirdest thing or the most out of the ordinary thing about Earth is that it's the only place that we know of with life, even of those 4,000 plus exoplanets that we found. None of them really seem capable of holding life like ours. So maybe we are very unusual and special, but even if we are, there are bound to be many, many other planets like our own. The idea of us being the only life in the universe is just so slim.
And indeed, both a comforting and yet absolutely terrifying thought.
I'm thrilled about that. And that's one of the reasons we study exoplanets. Let's find out who are our neighbors. Wasn't Kepler looking at a very small section of the sky? How big was it? Yeah, so you see that like blob there? That's like a lot of exoplanets.
Ooh, well, here.
Yeah, right there. So that's a lot of exoplanets all in the same area. And it's not because, you know, a bunch of planets decided to congregate in that area of the galaxy. That's where Kepler was looking, and Kepler was looking there for a very long time. If I remember correctly, it's because something kind of broke, so it couldn't look everywhere.
Oh, that does sound kind of familiar. I'm also not 100% on that though.
I'm pretty sure that's what happened. So it was just like, well, let's keep looking at the same patch of the sky, which was really neat because there are just so many in just that spot. So imagine that amount of exoplanets in that small thing, but all over the sky. Maybe in a number of years when we pull up our exoplanet catalog, it's just going to be multicolored all over. And we're just going to be like, well, trust us, those are exoplanets.
Yeah, we'll see if we can go ahead and fly through them one more time.
Oh yeah, it's really neat. I really like flying through stars and exoplanets because it kind of, like Amanda was saying earlier, it gives you an idea of the fact that these are really far apart from each other. It's just not, it's not like dots on a sphere. You can see they all get further and further away, and that's what the different colors are. Their whole big rainbow section here.
It's flying backwards, so I can't quite get into it, but
yeah.
I tried for you guys. I did that for you.
It looks cool. So we've got, is time traveling possible? You are time traveling right now at 1 second per second. Time traveling depends on kind of your definition of it. If you go really, 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 really fast, like nearing the speed of light, your time becomes slower. So when you stop and come back, you'll have aged less than someone who didn't. So you can consider that kind of a bit of time traveling. As far as like hopping in a time machine and going back and forth, as it stands, the math doesn't look great for it. It doesn't look great for it. But just rest assured, you're always traveling to the future at a very steady rate. Yeah, Jeremy said 2 of Kepler's reaction, or two of the wheels on Kepler broke, so it couldn't turn anymore. So that's why. I think it's cooler that we looked at the same patch of the sky, though, because we really get a better idea of that. I think we are about at time. Thank you so much, everybody, for tuning in, hopping in the chat. If there are any questions that you have or think of later, feel free to either leave a comment on this video or you can go ahead and send it to our submission page. The link is in the description. But thank you again so much. That's all the time. We really appreciate you showing up, asking questions. We love that. And don't forget to tune in next week, same time, same place. So March is going to be all about water. So look forward to it. So as always, if you enjoyed the video, drop a like, drop a comment, send it to someone else you think might enjoy it. Subscribe, turn on alerts so you can get notifications for more videos like these.
Yeah, thanks for joining us, guys.
Yeah, thanks everybody.